Hey guys, welcome back to Building Your Own Cyber Lab at Home with Kyle Slazik, and welcome to section 3, the build section. And so in this section, we're going to talk about things, some software that will help you build your lab, and mainly we'll talk about virtualization in this section, but we'll get into a little bit of physical lab building. So in this lecture, I wanted to give you an introduction to virtualization, because virtualization is such a heavy topic in this course, and it's such a great product, great software, that I think you should understand how it works in order to better build your lab. So I want to talk about three things. I want to talk about resource allocation, snapshots, and networking. Those are three very distinct things that VM and virtualization do differently than physical hardware. So first I want to show you this little picture I built here. This is how virtualization works. On the very bottom you have your PC hardware, and within that PC hardware you have your resources, your CPU, your RAM, and your hard drive space. These are the three main resources that a computer needs. Now on top of that PC hardware sits the hypervisor. The hypervisor is a small piece of software that basically allows it to share those resources, share the CPU, share the RAM, share the hard drive with the VMs that it's controlling. Now the hypervisor can be anything from VMware ESXi, which is a very, very small, we're talking under 100 meg. That's the operating system, that's the hypervisor. Or you can use desktop virtualization software such as VMware Desktop, VMware Fusion, whatnot. And so on top of that hypervisor sit the VMs. And so the hypervisor doles out the resources to those VMs. So in VM1, maybe you want to have a single core CPU. It will take a single core from the PC hardware and dedicate that to that VM. And maybe you want to give that VM a gig of RAM and a 20 gig hard drive. Well, the hypervisor will carve out a gig of the physical RAM and give it to that VM, and also the hard drives in virtualization are just files. So you'll have a 20 gig file on the hard drive, and that's the virtual hard drive for this VM. So the hypervisor does all of that doling out. So let's talk about snapshots real quick, because snapshots are really important when you're talking about a lab environment, because you get to take a point-in-time version of that VM. So what do I mean by that? When you build a VM, you're interacting with it, you're changing it, you're adding files to the hard drive, you're changing settings. When you take a snapshot, you take a version of that in time. You continue to use it throughout your using of your lab. If, for example, you run through and install some software on a VM that maybe blue screens the VM, well, you can revert back to that snapshot and it's like nothing ever happened. It goes back to that point in time backup. So this is perfect for saving the states of your VMs. My suggestion is when you start this, take a snapshot at the beginning, right when you install your operating system, you install your VM. That way, if you make changes, you screw something up, you can always revert back to a clean state. Now, it is important to note that snapshots take up space, and so you have to make sure that you have enough hard drive space in order to support single snapshots or multiple snapshots. And we'll talk about how to take snapshots in future lectures when we talk about the actual software that we're going to use. All right. So the last thing I want to talk about in our introduction to virtualization is networking, VM networking, because it's a little different than normal networking. In a VM, the hypervisor is also going to be doling out resources as the NIC, the network interface card. So you have three options when you're talking about a virtual network. You have bridged, which means that the VM is going to share the NIC of the physical hardware, whether that be a wired-in module or a wireless NIC. So both your host PC hardware and the VM will have two separate IP addresses, and that the hypervisor will maintain that communication so both can actually talk out to the network. Next, you have NAT, and essentially what will happen is the hypervisor will act as a router. It will have a border IP address, which is the IP address of the physical host, and then internally will dole out internal IP addresses to all the VMs and do the network address translation that way. And then finally, you have internal only, and this essentially means that VM to VM communication happens internally to the machine. They have no connectivity outside. You are setting up a virtual LAN for these VMs to talk to each other, but they won't be able to talk to anything else outside of that virtual LAN. So, for example, your PC hardware, your physical hardware, will not be able to communicate to these VMs via the network. So this is good for testing potentially dangerous software. If you're looking at malware samples, you should have a VLAN, a virtual LAN that's just internal only, and allow just that VM to talk on that LAN. So that's your introduction to virtualization. In the future lectures, we're going to deep dive into the actual software. We'll do some examples on how to build VMs and kind of what you want to do and what the software looks like. And we'll go from there. So we'll see you guys in the next lectures.